Please keep in mind that you can print this PowerPoint, and I would highly encourage you to print the supplemental worksheet if you have access to that. I'm going to be using it for a lot of this lesson, actually. And when you print the PowerPoint, the graphs are going to print kind of small, and since it matches exactly what's on the handout, that might be a great idea for you. And then if you've got questions or comments or concerns or thoughts, please feel free to share them as always. So in this warm-up, we're going to start off with a skill that's kind of separate. I haven't really done it in any of the other video lessons. It's kind of an extension, but we're going to write an exponential. We're going to write the equation of an exponential function that contains these 2 points. So I know 2 of the points, and I want to actually write the function. So especially if you did the supplemental material, you definitely probably saw this. A times b to the power of x is what I want this formatted. There's not going to be really any transformations. It's just I want to figure out what is the starting point, right? That a is going to give me the y-intercept, and b is going to be the growth or decay factor, right? Or like the multiplier, I guess, if you want to give it a really unfancy name. So I have 2 x's and 2 y's. So I'm going to go ahead and I'm going to actually write them. I've got -12 equals a times b to the power of -2. Then I also have -3/8 equals to a times b to the power of 3. So as x gets bigger, what happens to y? Does that get bigger as well? What is this going to look like? I want to think about, is it, so -2, -12. So there's like a reflection that happened clearly, right? And then 3/8. So it's going to look like this. So you can kind of see like there must have been some, it must have flipped down. So let's say I just flipped it back up and I pretended that it wasn't doing that. It's decaying, right? So there was obviously a reflection over, which is a good thing for us to talk about as we transition into transformations in a moment. There was a reflection over the x-axis, but if I negate that, it is a decay function. So my b value, b should be somewhere between 0 and 1 because it's decay. Okay? It's not really, like, it's not going to be detrimental if you can't figure something out like that, but it is good to know. So I'm going to basically do like a systems of exponential equations. I'm going to divide one by the other so that I can eliminate one of the variables because I've got 2 variables and actually solve. What I would like to happen is I want my exponent to be positive. So if you remember when you're dividing, one of the properties of exponents, if you're dividing and there's the same base, you subtract those exponents. So I'm going to choose to put this one in the denominator because I want to be able to do 3 minus -2 because that's going to be something positive. If I put this one in the denominator, I'm going to get a negative exponent. It won't matter. It'll be fine. I'm just trying to think of a way that I can eliminate some error for myself. But you're more than welcome to try it the other way. So the a's will cancel. So if I've got -3/8 divided by 12, that's like multiplying by 1/12, right? Multiply by the reciprocal. So what does this do? Well, it's not going to be negative anymore. This becomes a 1 and this becomes a 4, right? 3/12 is 1/4, so I end up with 1/32. So 1/32 equals b to the power of 5. And I feel like we solved this one in an earlier lesson. I'm going to take the 5th root, or I'll raise it to the 1/5 power, which is the same thing. 1 to the 1/5 is 1. 32 to the 1/5 is 2. So that gives me b. So I can go ahead and now in my equation, I have y equals a times 1/2 to the power of x. It doesn't really matter which one you use. I think I'm going to use this one so I don't have to deal with fractions. So I've got -12 equals a times 1/2 to the power of -2. Well, if you raise something to the -2nd power, or a negative power, I can flip this. So this is like 2 squared. -12 equals a times, that's a squared, isn't it? 4. Divide by 4. And I get -3 equals a. So I've got y equals -3 times, I don't need that point probably, 1/2 to the power of x. So right from the beginning, when I graphed this, I said, oh, there's got to be a reflection over x. Oh, that's what this negative is, isn't it? And we said, well, when I kind of ignore that reflection that happened, it's decay, so b has to be between 0 and 1, which is true. Right, so a little bit of an extension, a little bit going off in a different way, but this is a fantastic segue into what we're going to be talking about in this lesson, this last lesson of Unit 7, which is going to be transformations of both exponential and logarithmic functions. So the objective of this lesson is to use some background knowledge we have about functions in general and transformations in general, which we have spoken about with every function. Then you also have some experience, even though it's so long ago, from like geometry and algebra 1. But don't worry, I got you. To identify, right, like to verbally identify and or sketch those translations and dilations of exponential and logarithmic functions. So if you never did the Unit 7a supplemental materials, don't worry, you're going to get it through this lesson. So this first one, given f of x equals 4 to the power of x. So that's our parent function. I want you to think about what transformations are happening to go from f of x to g of x. So there's a few things highlighted. This 2, this 1, and this -2. So there's actually 3 things, because 3 things are highlighted. 1, the first thing that's happening is there is a vertical stretch. It's like a dilation of 2. The next thing that's happening is that 1. That's going to make it translate right 1. It's a translation. But think about like every function that we've dealt with, like what's happening with that. And then that -2 at the end is going to make it go down 2, also a translation. To extend on this a little bit, I guess a lot of it, I want you to think about what these actually impact. This vertical stretch is going to impact your y coordinate. Moving Moving right 1 is going to impact your x coordinate, and moving down 2 is going to impact your y coordinate. Right, so if you think all the way back, like let's say I wanted to look at f of x, and even in the last video lesson that I talked about, I said, well, we're going to focus on those points 0, 1, 1b, which is 4, and then let's look at the transformations that are happening. Well, a vertical stretch, that's going to impact y. I'm going to be multiplying, right? So I'm going to have 2 and 8. Done. And then I move right 1. Oh, that's going to impact right 1. I'm having issues with that word. This is now going to be 1 and 2. And then it's going to go down 2. Well, now this is going to be 0, and this is going to be 6. So g of x, I now have 2 coordinate points that it goes with, right? I now know I've got 1, 0, and 2, 6. And I could go ahead and graph it. I also want you to think about, well, f of x, if you were to graph that, doesn't that have an asymptote at y equals 0? Well, that a horizontal line, which one of these, 1, 2, or 3, is it going to be impacted by? Is that going to be impacted by multiplying? No. Is that going to be, if you move a horizontal line left and right, it's not going to change. It's going to be impacted by number 3 right here, by this down 2. That's a star, boy. If you move it down 2, this is now going to have a, horizontal asymptote, no longer at y equals 0. It's now going to be at y equals -2. right? So think about what this impact actually has. Like read through it and think through it and pull on a lot of your background knowledge. So as I just said, so here are the transformations. And then we're also going to look at it with logs, right? We're going to work them together. So you have an exponential function and logarithmic function. Your A is going to be your vertical. I don't like that. I'm going to focus on vertical. Your vertical stretch, it's your dilation factor. Right? It's going to impact your Y value. I don't want you to worry about this. That C in both of them is going to be your horizontal shift left and right. And I always want you to think opposite. And then that D is going to be your vertical shift up and down, right? I want you to also keep in mind, I'm going to add this in here. This has an asymptote that is, what is it? Horizontal, which is Y equals 0. Y equals a number, right? It starts at Y equals 0. So if you have a horizontal line, it's going to be affected by D. Right? This one has a vertical asymptote at X equals 0, right? Or X equals some number, I guess I should have said. Well, if you have a vertical line, it's not going to be affected by moving something up and down. It's not going to be affected by a vertical shift. It's going to be affected by a horizontal shift. This is going to be affected by C, right? So also think about the letter. Oh, it's X equals. It's going to be affected by where is X moving. And this is a Y equals something, like a horizontal line. It's going to be affected by, well, where is the Y moving? Okay. So I want you to mentally sketch or think through what and it doesn't even have to be mentally, it could be actually graph it, what the parent function, like where it's stemming from, like base to an exponent or log of that base, log with that base. So label the horizontal asymptote, label that point 0, 1, and 1b, or label the vertical asymptote in 1, 0, and b1, right? So this is for, if it's on a horizontal asymptote, this is exponential, this is log. Determine where each of these are transformed to. Write down the dilation factor, write down the base, write down the horizontal shift, write down the vertical shift, like write what is happening so that if there is an error that's happening, we can analyze it and figure out where any errors are happening. And then go with order of operations, right? So I like to just go left to right when you're doing it, but multiplication should come before any addition or subtraction. And then plot and label and characteristics only if you're asked. Okay, and I think for the purposes of right now, I'm just going to ask for specific ones, but we'll talk about it. So again, this is the supplemental worksheet, and I'm just going to work through it with you guys on this. If you want to stop and do it, more power to you. Please do that. So this has its B, its base is 2, and its, I believe that's D was the letter I was using, is 3. I want to actually write out what it's saying. So like this is the base. And it's going to shift, translate up 3. I'm going to go ahead and do this little table. So 0, 1, 1, B, right? And then it only had one thing happening. It translated up 3. So this is going to become 4, and this is going to become 6. Right? So you've got 0, 4, 1, 6. That's not a 3, that's a 2. Isn't it? So then this isn't a 6. That should be a 5. My fault. And then this, remember it has a horizontal asymptote and it's going up 3. Your asymptote's now going to be at Y equals 3. Right? It was at 0, so now it's going to be 1, 2, 3. So I'll start with that. Horizontal asymptote at Y equals 3. 0, 4, 1, 5. And then I can, whoa, grow. 1, 5, 0, 4, Everything's labeled. The domain of this is going to be all real numbers. Your range, well, what's the lowest point it's going to go to? It's the horizontal asymptote. So it's going to be 3 to infinity. Now that we have that, let's think about what happens over here. So it's not 0, 1, 1b anymore. It's 1, 0, b1, right? This is going to make it go. The transformations is it's going to translate up 3, right? So x, y. What's going to affect y? So now this is going to be 3, and this is going to be 4, right? So this has a vertical asymptote. If I move something up and down, the vertical asymptote is still going to be x equals 0. So let's go ahead and start with that. So these are actually not inverses of each other, right? I would have had to say it was x minus 3 would have been the argument for it to be inverses, right? That's how I would have had to do this for these to be actually switched. So 1, 1, 2, 3. And then 1, 2. Oh, I kind of wrote where I wanted it. 2, 4. And then it's going to go swoosh. Right? So I think it's good to recognize that these are not inverses. If I wanted them to be inverses, the inverse of this, I would have had to say f inverse of x would have been, let's see, log base 2 of, instead of it going up 3, I wanted to go right 3, so it would have to be minus 3. Right, and this, the inverse of this would have to be 2 to the power of x minus 3. So not inverses of each other, actually. The domain of this, so I forgot to label the asymptote, x equals 0. The domain is going to be from 0 to infinity. The range is going to be all real numbers. Wow, I feel like I just said this. Maybe try these two on your own. This, left, 3. It still has a base of 2. So I've got 0, 1, 1, 2. If it's going to go left 3, that's going to impact my x values. Negative 3, negative 2. So if you take a horizontal asymptote and you move it left 2, oh, it doesn't move. It's a horizontal line going left. It's already going left and right. So it's still going to be at y equals 0. So I'll graph it. And I've got 1, 2, 3, negative 3, 1. And negative 2, 2. And that is the graph. Domain, all real numbers. The range, 0 to infinity. What if I had asked you for the x-intercept? None. It clearly doesn't go through it. What about the y-intercept? Well, to find the y-intercept, you'd have to plug in 0. I don't know why I did a question mark and a semicolon or whatever those are called. So you'd have to have 2 to the power of 0 plus 3, which is 2 cubed, which is 8. Right, so 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. I didn't quite get through it. That would have been the y-intercept. So what about this one over here? My graph is pretty ugly. I want a new color. It's not ugly. It needs improvement. I guess is a better way for me to say. Over here, I have log base 2 of x plus 3. So this is actually going to be going left 3 as well. So that's going to give me, instead of 0, 1, I've got 1, 0. Instead of 1b, I have b1. Left 3, negative 2, and negative 1. So what about if you have a vertical line, you move it left? Oh, that does change it. It's going to actually be at x equals negative 3 now. So -2, 0, -1, 1. -2, 0, -1, 1. So I can see what the x-intercept is. I'm going to ask you guys about the y-intercept in a moment. But the domain is going to be from -3, non-inclusive, to infinity, and the range is going to be -infinity to infinity. And what I wanted to ask was about, well, y-intercept. So log base 2 of 0 plus 3 is going to be up 3. Oh, wait, we can't put that into our calculator. We don't know that, right? The exponent that turns 2 into 3, not a nice one. In your calculator, you could do log 3 divided by log 2, right? That change of base formula. Let's see, what is that? Log 3 divided by log 2. So it's going to give you a nice 1.585-ish. Oh, I feel like I plotted it decently well, right? So you do have the ability to find it now that we know a little bit more. Let's keep going. If you haven't tried one on your own, maybe think about it for this. There's not too many more opportunities. So this is going to go, no, it's not. Right 1 and down 4. So where is your asymptote going to be? It's exponential. So we're dealing with y equals horizontal asymptotes. They're going to be affected by moving up and down. So -4. Okay, so 0, 1, 1b, right 1, 1 and 2. So it's a little bit hard to see now. Down 4, -3, and -2. So I have the point 1, -3. And 2, -2. And this is growing. So I can't see either x-intercept or y-intercept for this one. So let's do both. Let's say I want to do the x-intercept. Just going to do it all the way up here. So the x-intercept is where y equals 0. So it's the whole function equals 0. Whoa, that's a minus sign. So I'm going to add 4. Ooh, this is a nice one. 4 equals 2 to the power of x minus 1. So I can actually change this, right? I don't even need to change it to be a log because I can actually change the left side. So it's 2 squared equals 2 to the power of x minus 1. And ignore the bases. So 2 has to equal to x minus 1. Is this right? Oh yeah, this is the x-intercept. So x is going to be 3. So I must have mixed it slightly. Pretty cool. What about the y-intercept? I'll do it all the way down here. That's going to be where x is 0. So 2 to the power of -1 minus 4. Well, that's 1/2 minus 4, which is 1/2 minus 8/2, so -7/2, or -3.5. That was pretty good. Right, so think about how you would also algebraically be able to find those. I'm going to get a new color since I wrote a lot. Okay, let's see. This is going to also go right 1, down 4. Let's see if I have a horizontal asymptote. No, I don't. I have a vertical asymptote. It's going to be affected by me moving left and right. So my vertical asymptote is going to be at x equals 1. It's not 0, 1, 1b, it's 1, 0, b, 1. I go right 1, so this is 2, and this is 3, and then I go down 4. -4, -3? Yeah. So I did both of these. So 2, -4, 1, 2, 3, 4. And then 3, -3. Ooh. Pretty cool. The domain of this, oh, I never did this one. The domain was all real numbers, and what was the range? -4 to infinity. This domain is -1. Oh, no, it's not. Ignore me. 1 to infinity. Now don't ignore me. And the range is all real numbers. I'd love to do the x and y intercepts for this one, and then I won't put you guys through it for every single one. Is there another one? I don't even remember. I don't even know how many more I have. Yeah, I have 2 more, right? Yeah. So I'll do it for this one, and then I won't even do it for the last one. Maybe. I'll see how I feel when I get there. So if I wanted to do the x-intercepts, why did I do blue? It's okay. I'm going to set it equal to 0. So 0 equals log base 2 of x minus 1 minus 4. I'm going to add 4. 4 equals log base 2 of x minus 1. And now I'm going to change this to an exponent, right? So the exponent that turns 2 into x minus 1 is 4. So 2 to the power of 4 is going to equal to x minus 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, equals x minus 1. If you add 1, 17 is x. So your x-intercept is going to be all the way down there at 17. It will eventually get there, though. Your y-intercept, I don't know where to go, is going to be where x is 0. So this is going to be log base 2 of x of 0 minus 1 minus 4. So it's going to give you log base 2 of -1 minus 4. And what's the issue here? And maybe visually you see it and you were like yelling at me on your side of the computer to stop because it clearly doesn't cross the y-axis. Well, the argument must be greater than 0, right? And since this argument is not greater than 0 when I plug in to get the y-intercept, there is no y-intercept. So keep using those rules, keep referencing them. It all goes together. So the last 2. Again, if you haven't tried any on your own, maybe try them. This kind of is like where we almost started, right? So 2 is going to be a dilation factor. So this is going to be a vertical stretch by 2, and then it's going to go up 4. So that means that your horizontal asymptote is going to be y equals 4 because it went up 4. So 0, 1, 1, 1/2 is now your base. It dilates by 2. So this is going to be 2, and this is going to be 1. And then it goes up 4. So this is going to be 6. This is going to be 5. So I have 1, 2, 3, 4. The only thing I don't like that I didn't do, and maybe I'll talk about it on the next one, I guess I kind of talked about it in the warm-up, is 0, 1, 2, 3, 4, 0, 6, 1, 5, and it, decay. Right, so your domain's all real numbers. Your range is going to go from 4 to infinity. There's no x-intercept, and we actually know what the y-intercept is, so I'm glad I didn't save it for this one. This one is going to have a vertical stretch by 2, and it's going to go up 4 as well. It's not going left and right at all, so your vertical asymptote is just going to be x equals 0. Oh my god, I didn't label this one. So it's not 0, 1, it's 1, 0, b, 1. Vertical stretch by 2, that's going to stay as 0, that's going to become 2, and then it's going to go up 4, so 4 and 6. So I've got 1, 1, 2, 3, 4, and 1/2, 1, 2, 3, 4, 5, 6. And it's going to look something like this. Your domain is going to go from 0 to infinity, and your range is going to be all real numbers. The only thing I don't like that I didn't include anywhere except really the warm-up is a reflection, right? And you guys have learned about reflection before. We've done it in other functions, and you've done it in general. But let's say I did something like y equals, and maybe I'll do it on the next page, but I had if I have that negative in front, it's going to make it flip down. So let's do one more example actually on the next page. So before we summarize what we did, what if we had y equals -3 2 to the power of x minus 1 plus 6, right? So this is going to be a vertical stretch by 3. This is going to go right 1. I'm going to go up 6. And this is going to reflect over the x-axis. We're not going to talk about reflections over the y-axis. Like, you're not going to have a multiplier in front of x. You will do that in pre-calculus next year, but I definitely don't need to do that with you guys now. If you're curious, explore it, but I definitely don't need you to. So if I was going to go ahead and do this, 0, 1, 1, 2. So vertical stretch by 3. You know what? I'm going to combine these two into one because some of you guys might say it's a vertical stretch by -3, right? So this is going to become -3. And this is going to become -6. And it's going to go up 6. So 3 and 0. And then this is going to be 1 and 2. So let's see what that looks like. Y is going to be equal to 6 for this. So if I did this correctly, the whole thing should be happening down here. So 1, 3, and 2, 0. Yep. Right, so something like this, your domain is still all real numbers, but now your range is going to go from -infinity to the asymptote, which is 6. Right, so this is still growth, but since that reflection happened, so you have to, and that was kind of where I started with the warm-up, you have to think, well, if I took away the reflection, it is growth, and that's why b is greater than 1. And it's the same thing like if I had done one that was negative log of x plus 2. Right, so let's see what happens here, and then I'll leave you guys. Maybe you already stopped me, I don't know. This is going to go left 2 and reflect over x. So I'm going to start with the points, and let's see my asymptote for something like this. If it goes left 2, your asymptote's going to be x equals -2. It should still be to the right of that line. It should not be to the left. Like, nothing I didn't say it reflected over the y-axis. It's still reflecting over the x-axis. That would happen if I made this x value negative, which is not something you're going to see. So it's not 0, 1, it's 1, 0, b, which is 10, 1. Reflected over the x-axis, so my y's become negative, 0 and -1, and it goes left 2, so -1 and 8. So it's -1, 0, and then 4, 5, 6, 7, 8. 8, -1. It's an annoying one. So it's like this. right? So whereas it would have been increasing otherwise, right? So I would have had like, it started off as 1, 0, 10, 1. So it would have been increasing. It reflects down, like it flips down. So what we did in this lesson was we used some of our background knowledge about functions and their transformations and then what happens with transformations to identify, right? We wrote it out. What are the actual transformations? We sketched it and labeled it. And we talked about some of the characteristics and wrote some of the characteristics and even brought in some of the algebra for both exponential and logarithmic functions.